Hi everyone, in this video let's discuss about the multi-tenant architecture. So if you are a software engineer, you have heard about this term multi-tenant architecture or multi-tenancy. So let's discuss what does it mean. So first we need to understand what is a tenant. So in the field of software engineering, a tenant is a customer who is using your software. So imagine that you have built some software and there are multiple users who are using that software, and so those users are your tenant. So for example, suppose you have built a SaaS known as a user management portal. Okay, multiple companies are using that portal to manage their users. One company that is using this product is that ABC Private Limited, another is the XYZ Private Limited, another is probably Netflix, and some other thing is Google. So these things, these separate companies are your tenant. So you have one tenant called ABC, another tenant called XYZ. These are the tenants. So these are the customers who are using your software. So the customers who are using your software, we call them as tenant. Okay, so now your software is pretty much popular and multiple companies are using your software. You have multiple companies like Google is using your software, XYZ, ABC, they are using your software. Okay, as and when multiple users or multiple companies are using your product, then where you should store the data for specific users. Okay, so one thing you can do, suppose that for specific companies you are creating a separate database, separate server for managing the users for that company. So for example, suppose for the employees of the Google, you have created a separate database and you have a separate server in which the database only stores the users for the Google company, and the server only handles the traffic related to that companies who are employees of the Google. So similarly for the other two companies also, you have dedicated database related to that company. Okay, so similarly for XYZ also, you have a separate database which only has the users who works in these companies, and maybe you have another database who works in this company. So this way you are, for each of the customer or for each of the companies, you are creating a separate database and servers so that you can store and manage the data of a specific company in a separate database. So this is what we call it single tenant architecture, where for each and every customer, big customer, you are creating separate database and you are creating separate servers only for those specific users. Okay, so this is what the single tenant architecture mean. Now if you talk about the pros and cons, so if you, as you can see here, for each of the customers, each of the enterprise or each of the companies, we are creating separate database, right? So one thing is definitely true, that the strong isolation, so data is isolated because this database is only having the users from the Google, and it doesn't have any other users for any other companies, like it doesn't have any users from the XYZ or ABC. So this way definitely the data is definitely isolated. As a result, the data doesn't get mixed up or data doesn't get leaked. So one company users, they are not able to see the data from the another companies. Okay, but the cons of this system is that this is very expensive, because as and when your application is growing, you are getting more and more users, you are spinning up separate databases, separate servers for those users, and as a result infrastructure cost will go up. Okay, and again the deployment difficulty is also increases, because as and when you are getting new users, you are spinning up new databases, new servers, so definitely the deployment is definitely difficult here. And yes, obviously scaling is definitely a problem here, because as and when you are getting more users and more customers, so you are spinning up separate databases and separate servers for that, and that is definitely very much costly. So scaling is definitely problematic here, because here with the scaling the infrastructure cost increases rapidly. So that was about the single tenant architecture, in which for each of the users or each of the customers, we are creating separate databases and maintaining separate servers for them. Okay, so that was about the single tenant architecture. But the multi-tenant architecture, as you can see from this diagram, we are not creating separate databases, separate servers for each of the users. Instead, we are creating a shared database which will be shared by multiple enterprise customer or multiple customers, you can say. Okay, so if you just see this diagram, so as you can see from this diagram, these are your users. So your users are accessing the application, and your load balancer sends those requests to specific servers. Okay, you have multiple servers here to handle the scaling, and now all those servers are running the same application logic. Any users tries to access the application, and then they go a process called as tenant identification, and after that the data is stored in the database, and this database is shared database. That means the companies from ABC, companies from XYZ, Google, all of them are using the same database. Okay, because this is a shared database. So this multi-tenant architecture, we are not creating separate databases, separate servers for different customers. Instead, we are using the same database for multiple tenants, or you can say multiple customers. So this is why the name comes from multi-tenant, because within the same database we are storing multiple customers data. That's the reason the name is multi-tenant. So here in the multi-tenant architecture, in the same database, we are storing the multiple tenants or multiple customers data in the same database. Okay. So here what happens is the database is the same and the table might be same or might not be same. Okay. So you might want to choose, you might want to create different tables for multiple separate customers, or you can use the same database, same table itself for storing data. Now, how we are going to store the data of multiple customers within a single database? Let's discuss about that. So there are multiple strategies which we call it database strategy, using which you can decide how you want to store the data for the users. Okay, so this is the most common pattern that we are using here. So here we're using the same database for storing multiple users data, multiple customers data, and we are using the same table. Okay, so that means the same database and same table contains the data for users across multiple tenants. So in this approach, we are using the same database and the same table for storing data of multiple customers. So if you just see the table here, this is our users table. Okay, so you can see we have stored multiple users data who are not from the same company, who works in different companies. Okay, so in the same table itself, we have the data of Bob who works in Google, and we have data of Alan who works in ABC and other companies as well. Okay, so basically within the same table, we are storing the data from multiple tenants or multiple customers. Okay, now here one important thing is that this tenant ID. Okay, so now the question is like, since within the same table, we are using the same database, we are using the same table, and within the same table itself, we are storing the data from multiple customers. So we need to know, need to have a mechanism to identify which users is from which company. Okay, it might happen that there is an employee called Bob who works in Google, and there is another employee whose name is also Bob and who works in ABC. Okay, so how do you differentiate that which Bobs works in which companies? Now that because you have within the same table, you are storing multiple users data. So the answer is tenant ID. So you need to always track the tenant ID, because that is the source of truth for using which you can identify which user belongs to which company. Okay, so if you are using this database strategy, you are using the same database and same table for multiple tenants, so you need to have a column called tenant ID, and whenever you are doing some query to the database, you need to provide the tenant ID, because using that you can ensure that one employee from one company is not able to see the data from another company. That's how you maintain the data isolation here. Okay, so you need to always store the tenant ID, using which you can identify that the user who is interacting with your application belongs to which tenant or which company. And there is a detailed mechanism about how do you identify that the user is from which tenant, that we will discuss later. So there is another strategy that you can follow where you create separate database per tenant, which we talked about earlier. So here you just, for each of the customers, each of the companies, you are creating separate database. Okay, now the benefit of this is that this is very good for the data isolation. Okay, and this is also helpful for when you need to maintain the data security compliance. Okay, because in this case you are creating separate database for separate companies, so this is very good for the data isolation, and also the scenarios where you need to ensure that you are following the data privacy compliance. For that scenario, this is very good, and this is also easy to maintain the backup and restore, because for each of the database we are having the data for a single customer, so it's very likely that the database size will be less. Okay, so since it's a small database, so it will be easier to maintain the backups and restore for a single customer. And also, since in this specific database you are storing the data for a single customer, one customer heavy workload will not directly affect to another customer, because this is very self-explanatory, because in one database you only have the data for a specific company, you don't have any other company's data here, so the database will not bottleneck. Okay, but whereas you would have chosen some shared database, within the same database you have users from multiple companies, then if one of the companies are performing some heavy operations, then it might happen that the database might be a bottleneck, and that will affect all the companies whose data is stored in that database. So, but that's not happening here, because we are maintaining separate databases per tenant, so one customer heavy workload will not affect another customer database. Now, apart from this, there is another mechanism that the companies follow. They follow both. So it's not like they only follow the single tenant architecture or they follow the multi-tenant architecture. Instead, they follow both. Okay, so this is what we call as hybrid architecture. If the customers are small customers, okay, so suppose that single user customer, okay, it's not an enterprise customer, it's a single user customer. So in those scenarios, the companies use the shared database and the shared table. And for the enterprise customer, for which the data isolation is very top priority, and performance is also top priority. For the enterprise customer, the companies creates dedicated servers and dedicated database. So as you can see, if there is a small customer, we are storing the data in the shared database and shared table. But if it is an enterprise customer who requires high data security, high performance, for that we are creating a dedicated instance in which only the data of that enterprise will be there. And that way we can easily follow different data isolation and the data compliance rules. And now, how do you understand and how do you differentiate that which users you want to store in the shared database and for which users you want to create dedicated instance? Okay, one thing you can do that using different type of plans. Okay, so if you just visit any software application, right, if you just open any SaaS tool, you can see there is multiple pricing options. The first is the free plan, where users can directly use your application for free, and since they're free users, then it's okay to compromise with the performance. It's okay if the users gets the data little bit later, that's fine, because they are on the free plan. So for those free plan users, you can use the shared database. Okay, and for the pro users who are paying customer, you can choose the shared database, but maybe a little bit less. Okay, so free users will go in single database, but for the pro plan users, you can use the shared database, but the crowd in the database will be less, so that the performance is little bit higher. And finally, we have the enterprise customer, for which the performance is the topmost priority, and data security, data isolation is very much high priority. So for those users, you create dedicated instance. And here we have a diagram which explains end-to-end multi-tenant architecture flow. So if you just see this diagram here, this is your users. So users opens your application. Okay, they're visiting the application and they try to log into your application. They enter the email and the password. And the first thing you do is that your authentication service checks the email and the password, and it checks if the email password is valid or not. And if it is valid, from the user's database, it fetch the user information along with the tenant ID, and it creates a JWT token, and inside the token it stores the tenant information and the user information. Okay, and that token is stored in the database, and now whenever that users makes any further request, then that token is sent along with that request. Middleware server, it validates the JWT token and it extracts the tenant ID from the token. So suppose the tenant ID is 101, and now when your repository layer makes any query to the database, it puts that tenant ID as a filter item in the query, so that always you are making any query to the database, you are filtering the data and you are fetching the data for only that tenant ID, so that you are not seeing any, so that the users cannot see any data from another tenant. Once you have filtered the data, you are just returning the data to the response. Okay, so this is the main architecture diagram, and I think here this is the critical flow, because in the users database you already have stored all the users information along with the tenant ID, with which tenant do they belong to. Okay, and whenever that user just tries to log in, you are fetching the user information along with the tenant ID, and you are creating the token and storing the tenant ID in the token itself. And then whenever users makes any request, the tenant ID is fetched from the token, and the tenant ID is always used as a filtration for the database, so that user can only interact with the data which the user is allowed to, or to the same tenant in which the users belongs to. So that was an overview architecture about what does a multi-tenant architecture mean. So I hope this video gave you a basic idea about how does multi-tenant architecture work. Let me know what you think on this one, and as always, thanks for watching.